Good morning everybody and welcome to today's webinar. So this webinar will be around 1 hour in duration, and what we're going to be discussing today is the upcoming functionality going to be released in MASTA 11.1, which is the SMT Geometry Modeler. So the SMT Geometry Modeler is an SMT supplied CAD package. First and foremost, it is designed to assist you with your modeling process, although it does have the ability to be a full suite CAD package as well. So you can actually create models from scratch in here as well. So it would take much longer than 1 hour to show you all of the functionality available within Geometry Modeler. So I'm just going to sort of briefly touch on the main points in the next hour or so, and then in the coming weeks, probably just after the actual release, then I will organize a much longer training session, so one of our 3-hour workshops to show you its major capabilities and how you actually use this software package. So if you have any questions as we're going through the webinar today, please feel free to ask them in the questions panel on your GoToWebinar window. Can't guarantee I'll get to them during the session, but I'll either answer them at the end or I will get back to you at a later time with an answer. So one of the major benefits of the Geometry Modeler is that it is an SMT provided package. And what this basically means is that there is absolutely no need throughout the entire transmission design, analysis and optimization process to deviate from the SMT family of software products. So as such, the licenses are sorted out by SMT. There's a very strong link with MASTA, so you can pass information to and fro between Geometry Modeler and MASTA at the click of a button, and I'll show you some of that today. So there's a couple of different scenarios I want to focus on and I want to cover. Scenario 1 will be familiar to a lot of people. So this is if a design already exists within a CAD capacity. So let's say you've already got a 3D version of your transmission model and you're trying to create that from within MASTA. So I'll show you how you can quickly use the link between Geometry Modeler and MASTA to actually create your fully detailed MASTA models in no time at all. And then scenario 2 is probably slightly less used, but where you have the internals of a transmission concepted in MASTA. So let's say you're actually using MASTA for the concept design stage of your transmission, and you actually want to take this to a CAD package to actually start generating your housings, for example, or to start generating more detail in your asymmetric shafts. So I'll go through very basic examples of both of those methodologies today. So as I mentioned, what I want to start off with is scenario 1, which is if you have a design which already exists in CAD form. So this is a model that many of you will be familiar with. It's our very basic single speed 2-stage EV model, and we'll be using this as an example today. And what I want to start to do is to utilize the CAD model here and bring it into MASTA. Now, the file format we have here is one which has been saved in Geometry Modeler. However, models from all the major CAD packages can be opened within Geometry Modeler. So SpaceClaim, CATIA, and so on. You can open those models within Geometry Modeler for ease of use, as well as opening files such as step files, so the usual Exchange format. Once they're open within Geometry Modeler, very, very easy to start constructing both components and FE components. So there's a lot of different options up here, some of which we'll cover today. First thing I'm going to focus on is this MASTA tab here. And this is where we actually link, or a primary link between Geometry Modeler and MASTA. And what I'm going to start to do is utilize the CAD geometry to create some of our MASTA components. And I'll just try this on a couple of different components just to show you the capability. So I'll start off with this shaft here, for example. I could model it directly from here, but I might isolate it just for ease of use. And all I'm going to say is add component. And what this does is it activates a feature that a lot of you will already be familiar with in MASTA. So the same kind of feature you'd have seen when importing 2D CAD geometry into MASTA and modeling using either a DXF or a DWG. It's the same functionality within MASTA itself, however it's now linking to our geometry modeler. So I can say, for example, I want to add a shaft component. It says what I need to select in order to generate that component, so 2 vertical and 2 horizontal lines. So I can select those within Geometry Modeler. You'll see that the boundary box has been created in MASTA based on those selections in Geometry Modeler, and I can add that to my model. Now, before I add any more components to this, I want to actually modify that shaft profile. That is done with the next button along, so define shaft profile. Again, that just activates our shaft profile tools, and I can just click on the associated geometry and it will create that for me. And this works with both the outer and the inner profile. I've got very powerful sectioning tools available in Geometry Modeler, allowing me to visualize and select those internal vertices. Like so. So we now have that shaft component. And what we'll find is that the shaft component has been created in exactly the same coordinate system as the original model. And this actually makes it very, very easy to complete this entire process. Because we've got everything in the same coordinate system, so if I show all of this again, it means that if we're creating all the components in that coordinate system, when we start to come to generate the housing components and send it over to MASTA, again, they're in the same coordinate system. So there's no playing around with positioning or anything like that. We know that everything is in exactly the right place, ready to be connected up. Okay, so next I'm just going to add a couple of components onto this shaft. So I might start off with this bearing here, for example. Again, very easy, just add component. Select the required lines for this. And then once all those are selected, we can choose our bearing designation. I'm just going to pick any one of these to begin with. And add that to our model. And again, we now know that it's in exactly the right position. It's connected to exactly the right component. And we're happy with how that's proceeding. So the one last model I'll add here is these two gears. So this gear pair. Again, I just select on the component I want to add our existing component to. Select what it's going to be in this list down at the bottom. It says I only require 2 vertical lines here. I can select those. And then I can put in some basic gear geometry if I like to get this started. So our selection here is controlling the actual positioning of the gear. We put in some gear geometry down here. I'll leave that as default for now, so this will look wrong to begin with. And then to do the meshing gear, I can say connect to this gear another cylindrical gear. Select the appropriate lines and positioning, and again, add that to our model. And you can see how quickly we can start to build up our MASTA model. The other thing we can do using this functionality is sending over components to use as FE geometry. So for this, I'm going to go over to a completed version of my model, like so. And then all I'm going to do is to select the components, select the bodies that I want to send over. So in my simplified model here, the whole housing has been combined into one solid body, but you can send them over as individual bodies as well, if you so wish. And what I'm going to do is say send geometry. Now we have that existing link with MASTA, so it's now saying, okay, well, you want to create a new FE component. If I go to my FE mode, that has been brought over to MASTA as an STL format. So that's basically, it's not a mesh, that is faceted body. We then have meshing options available within MASTA itself. So I can modify some of those and then attempt to mesh. Now I know for a fact that this first attempt here will fail, but that is a good thing in this case because I want to show you something. So this is a problem you'll see in pretty much any meshing package that you try to use. It's not a first-time solution in many cases. There will be places where your geometry needs a little bit of tweaking in order to be able to effectively mesh. One of the powers of this link between MASTA and Geometry Modeler is the ability to very easily identify where these problems are. So for example, this one's saying the problem is intersecting triangles. I can show it in MASTA's 3D view where those problems are. So we can see there's a couple of problem areas here, but can also say show it in Geometry Modeler. And this makes it very, very effective in terms of trying to repair our problem geometry. Now there's a lot of tools that we could utilize here to try and repair these problems. So we do have lots of modeling capabilities, so we could completely change the geometry in those areas if we wish to do so. So if I focus on this one, for example, here. However, we do have a lot of geometry repair and prepare options available to us as well. Now I won't go through all of these today, but if I just show you some of the available repair options, it is basically things to allow you to make a more suitable geometry. So getting rid of some of the unusual features that might cause problems further down the line. So for example, if you've brought in a model and it's just a range of surfaces, which is not too uncommon, you've got the ability to solidify these using various options. You can remove extra edges and duplicate edges. You can fix any curve gaps or remove any small curves. You can merge faces into one larger face, simplify the whole model, fix inexact edges or fill in any small faces with the surrounding faces. It's all things to make your model simpler and easier to mesh. We also have the prepare options. Now, this again is just tools to try and help you to set your model up for further work. And it's options here such as identifying interferences, removing rounds or removing faces, fixing any, or detecting and then allowing you to fix any bad faces. Various options which will be discussed in more detail in additional tutorial videos a little bit in the future. So what I might want to do here, for example, I can see there's a little bit of mismatch between the two faces that are next to each other. So I might say that I want to simplify this particular model. Maybe I want to remove this round and just make it a sharp edge just for this demonstration purpose. So I can say I want to use the rounds option, click on the faces I want to modify and try and fix those. I can see there that that round has been removed. You can also see that there's an additional line which has been left, but I should be able to just select and delete that. And I can see that geometry seems to be a lot tidier now than it was. Now, at this stage, I don't know if that's fixed my problem. So I can just go back over to MASTA and just hit this button which says Reread Mesh from Geometry Modeler. That will basically get the mesh information from over here, or get the geometry information from over here, and bring it back into MASTA for us. So now all I need to do is hit Mesh Volume again and see if those changes have been successful in resolving our issue. So in this case it hasn't, but we did have 2 problem areas. So let me see. I can see now that I've only got 1 problem area. So the one that I added in here seems to have resolved our problem. I just need to have a look at the bottom end of the model now. In this case, I may just be able to lower the element size to get around that problem. But you can see as a result of this, we have got quite powerful geometry repair capabilities over in Geometry Modeler, and its link with MASTA does allow us to resolve these issues quickly and efficiently. So you can see there in a matter of a couple of minutes, and granted this is a simplified model, but it gives you an idea. We have a mesh that's been generated for us from geometry that was sent over from Geometry Modeler. When we're at this stage, it's if we've just imported an FE component, as you've seen in MASTA many times, most of you, and then we're able to just go ahead and create condensation nodes, actually link our component up to the rest of our MASTA model. Okay, so the next part of the process I want to show you here is bringing over a shaft, replacing a shaft with an FE component, but also saving some aspects of that shaft as parameters, which can then be driven in MASTA. So the item I'll be using to demonstrate this to you is one of the gear blanks. So let me just refine that down. So we have this gear blank here. I've already removed the gear teeth from it. What we basically have is a very thin gear blank with some asymmetric features in it. So a prime candidate for replacing a shaft in MASTA with an FE component. So what I'm going to do first of all is to actually send this over. Same process as before. I just select the body and send the geometry over to MASTA. Again, it's already in the right place, so I can very, very quickly just go and start creating a mesh for this. Also tell it which shaft it needs to replace, so in our case it's this gear blank here. So we can see within a matter of seconds there, we have replaced that shaft with a detailed, well, example in this case, FE component, where we have full control of the mesh. We have the teeth meshed on there as well, for example, and it's really easy to do. Now, the next step may be that we want to perform some optimization on here. Now, granted, we're at a slightly early stage for this now. We're still building the model. But what I can show you at the moment is how we would save certain parameters on here, or in Geometry Modeler, and drive those from within MASTA. And what this basically means is that we can drive these from a lot of the tools within MASTA to perform optimization studies or design of experiment studies. So what I'm going to do as an example is save a couple of different parameters on here. To start off with, I'll save the quantity of holes. So we may want to control the quantity of holes that we have drilled into this gear blank. So if I identify the appropriate property, so it's this count here, because this is a feature, go to groups and create parameter. I can save that as a parameter, so I'll just put hole quantity. I may also want to control the size of the holes, for example. So I'll go to one of the tools that's available for us here. I'll talk a bit more about this later on. Find the appropriate dimension and then create a parameter. And then I may want to control something a little bit more abstract. So let's say the thickness of this gear blank material here. So I could again just select, and then I'm going to go to this tool down here, which is the ruler tool, and then select what I want to measure between. And again, once we have a measurement highlighted, we can create a parameter. Now I've created those three things. All I'm going to do is go over to MASTA and say Reread Mesh from Geometry Modeler. It comes up with a message saying that there are different dimensions that have been passed into the model, so things that weren't there before. And then you'll see that on the Meshing Options tab, we now have those parameters that we saved have now been brought into our MASTA iteration. And what that basically means is that we can now go through and modify these. So let's say, for example, I want to change the quantity of holes and the hole radius. And then as soon as I hit Reread Mesh from Geometry Modeler, it will go over to Geometry Modeler, make those changes, and then bring it back into our MASTA iteration. And then as soon as I create that mesh again, you'll see that the teeth are regenerated. And if I'd made any condensation nodes, so we'll test that as well, then all of those condensation nodes will be recreated as well. So if I have this set up, for example, if I go ahead and make some changes, reread mesh from Geometry Modeler, and then mesh the volume, all of those condensation nodes which I defined are reapplied, so I don't have to re-add all of those settings again. Okay, and then we were playing with the blank thickness as well, so a dimension driven in a different way. So I can change that. Let's change it to something very low just to make it obvious. Reread the mesh, and again we can see that dimension is driven and brought back in for us. And because, as I mentioned, these are in MASTA now, these can be used as part of our design of experiment tools. So things such as the parametric study tool, runner, you can incorporate them into these studies, and it basically means that we can optimize and design CAD geometry whilst considering the full system model as it is modeled in MASTA. So traditionally you would have to create a new bit of FE for every single change you wanted to consider, send it over to MASTA, perform the analysis, and that's the process you would use in any tool like this. What this functionality allows us to do is to automate this entire process. So if we set up a parametric study which looks at the different number of holes, which looks at the thickness of the blank, it will perform those multiple studies for us and give us the results in terms of the full system model. And I'll set up a quick example of this now just to show you what kind of thing I mean. Okay, so what I'm looking to do here is to set up a design of experiment study which modifies a lot of these parameters that I've created and assesses the results of various parts of the system in conjunction with this. So I've got a simulation which has been run already, but I'll just show you the kind of thing to do to set this up. So for this one I'm using the parametric study tool, and it is literally a case of putting in various inputs and outputs of what I want to allow MASTA to change or get MASTA to change, and what I want to extract as the results. So a lot of you will be familiar with the settings in here. I can just choose the kind of simulation it is that I want to perform, and then set up the parameters I want to change. And you see that they are all contained within this list now. So all of those specific parameters that we've created are now available for selection. I can apply the numbers I want to simulate in here. I can put in various operations in this list as well. So for example, in order to be able to actually assess these, I need to perform some of the tasks in an automated way. So things such as the rereading the mesh from Geometry Modeler, that needs to be reperformed at every iteration, remeshing the volume and performing the reduction. And these commands can all be added to this parametric study tool simulation. So if I just find one or two of those, I've got re-import mesh from Geometry Modeler, I have create FE volume mesh, and I have perform reduction. So for every one of those iterations, those commands will be performed. Now I do have the simulation that has been completed here. So the inputs are pretty much exactly the same. I've just defined a few values as to what I want to run. So a few different hole quantities, a few different hole radii, and a few different blank thicknesses. And then I've set up a few things to draw out as part of the data logging setup. So only a couple of small examples here for that gear set in which this gear blank plays a part. I've asked it to look for peak-to-peak transmission error and to look at the total equivalent misalignment for rating. Now this is just to simulate that you can get results from anywhere in the system really. It doesn't have to be related to that gear blank. The gear blank is being incorporated as part of that complete system model. So we can extract results from anywhere in that system model. In this case, I've gone for the gear set and also the mass of that FE component, so we can see how the mass changes. So if I go to, make this a bit larger, if I go to charts for DOE, I'll go for a parallel coordinates, and I'm just going to start adding properties to this. So we can start to compare these simulations that we've performed. Okay. Okay, so this is one example of the chart that we can accomplish. So I've got all of my input parameters that have changed there, and then my output parameters as well. And there has actually been a significant change. So I can see that my mass has changed from 1.7 to 2.06 over the course of the simulations. I have a significant change in the peak-to-peak transmission error and a massive change in the calculated misalignment. But granted, those examples I utilize are probably quite extreme. So if I start just refining this down, so let's say I want the applicable misalignment to be a lot less than the maximum that was calculated. I want my peak-to-peak transmission error to be quite low as possible. And then I want my mass to be as low as possible. And what I'm doing is just refining down these capabilities to try and find the most applicable one for me. So in this brief example, I can see that run 45 might be the most applicable to me. So one of the lowest mass options, we have hole radius of 5 millimeters, blank thickness of 10, and a hole quantity of 7. So that's just showing the kind of thing we can do. So I automated the simulation there, which performed 45 different FE designs for me. And to do that manually and to get all of those results and collate all the results would take quite a long time. But in here we did it in a matter of minutes. So the next thing I want to demonstrate to you very quickly is the faceting capabilities of the geometry modeler. So what I mean by this, if I just pull up one of my models, so we'll just go with this housing here. So this is quite a simplified example, so maybe not the best use case, but we'll go with it anyway. A lot of the problems, even though those that we saw in that last example, might be to do with trying to get the mesh to generate properly and to be the quality that you want it to be. And this is applicable across all meshing platforms, more or less. So I've shown you one way of doing this defeaturing. So that was with the prepare and repair tools and just modifying the geometry. Another option, if you want just sort of a quick fire initial solution, is to actually generate the facets inside Geometry Modeler itself and to use a tool called shrink wrap to simplify that model, because it's the detail on the models a lot of the times that will cause those problems. Now this functionality is still being applied to the link between Geometry Modeler and MASTA, so the actual button to send it over is not there quite yet, but I'll show what the functionality is going to do. So if I go to my Facets tab up here, I can convert my model from a solid to a faceted body. You can see that it's generated those there. And then I have this option here, which is to shrink wrap. Now that basically, as the name kind of suggests, just shrink wraps over this particular model, and it kind of simplifies the geometry quite a bit. Now obviously it's going to be, let me just set that running while I talk. Obviously it's going to be an approximation of the actual correct unit that we make, because it's going to be very much simplified. Sizes might be slightly different, but if you want to just get an initial understanding of how your system might perform when it's simplified, then this might be the tool to do it. So basically, instead of having that whole detail, large amounts of detail which might not be able to mesh, we might now just be able to send this faceted information over to MASTA and then just connect it up in the same way. And we see, because it's faceted and because it's shrink wrapped, that the geometry has been simplified somewhat, but the basic shape is still there. So we can get an understanding of how that housing would perform. Now what we're intending to do is to have a button which allows you to send this shrink wrapped model to MASTA. At the moment it's not there, but it will be by the time release comes around. So what I'm going to do instead is I'm going to save that as an STL. And then I'm just going to bring that into MASTA. Okay, and what we can see there is we've brought that in. It's much simplified geometry. Obviously you could play around with the level of shrink wrapping and some of the other faceting options if you wish to do so. But what we should be able to do is to mesh that much easier than we could before, because it's been simplified. Okay, so the element size might be quite fine on this one, just based on the settings I've selected, but it has successfully been able to do this, as you can see. So none of those problems we saw before because of that simplified geometry, yet we are retaining the basic shape and stiffness of that housing component. So at this stage, as we've seen, I can just go forward, create my connections, modify my search regions if required, and run my analysis. Now obviously, depending on the stage you're at in your design phase, would dictate whether you go for the defeaturing approach, or just try and repair the geometry, or go for this shrink wrapped or faceting approach. But all of the options, all the considerations are there and available. Okay, so the second main scenario I want to talk to you about is in the event that the internals have been concepted using MASTA already. So basically you've used MASTA to create your concept transmission, and now you need to create a few components. So maybe you start modeling the housing, or you start adding some of the asymmetry to some of the shafts, for example. Now, this is another example of where there's going to be certain functionality at release, but it's not implemented at the moment. We are still in beta phase at the moment. But again, I'll show you what we are going to be doing. So what we're going to have within MASTA is a button which allows you to send your internal model geometry, save it as a step file automatically, and send it over to your geometry modeler installation. And as I say, at the moment that isn't implemented, so I'm going to do the existing method, which is to export our model as a step file. Should only take a moment, and then opening that step file in the geometry modeler. But just to reiterate, there will be a button which will do this for us automatically. And the reason I'm doing this is I want to show how easy Geometry Modeler can make the concept design process. So we've used it to concept a very quick internal section of the model, but now we can use it to start creating the actual housing components and the shafts, as I mentioned. Okay, so if I open that up, so that saved everything out in the actual coordinate system that MASTA uses. So everything will open up in the same coordinate system. This also means that when we start concepting new components and then send them back over to MASTA, that everything again will be in the same coordinate system. Okay, so there we go. So I want to start modeling a housing, and I might start modeling this section down here just to demonstrate kind of what we are capable of here. So again, just demonstrating some of the modeling capabilities. So I'm going to start off by generating a plane. Obviously, this is just an example of some of the modeling capabilities, not a complete list. I can say Projector Sketch. So this will give me the seats for my bearings. So it is a fully detailed CAD package. It's not just a gimmick with a few modeling capabilities. It has got all of the tools you would expect from a CAD capable package. So let's say, for example, I want to get rid of this sharp corner. Okay. Now the main 3D tools that are available to me that are really effective in the fact that they kind of simplify the whole process down to a few operations are these pull, move, and fill commands. So let's say I want to convert these to 3D shapes. I could say pull. Gives me those as surfaces to begin with. But then I could say, okay, well, I want to pull those. I want to pull it up to this face here, but I don't want it to merge it with the existing model. Okay, so that's giving me my first bearing mounting. Do the same again, up to here. Okay, so those are my bearing seats. Now say, for example, I want to create the main body of this housing, so something that will encompass all of those gears. And again, you can kind of see the speed at which you can generate some very basic geometry. Now, of course, what we're making here is not the finalized model, but we are very quickly starting to generate what could be considered part of this housing. Okay, and again, I could say pull. If I wasn't happy where that was initially sat, I could go move. That's one of my other primary tools. That basically allows us to position this handle and then move the selected component or components around that highlighted position. Okay, and again I could say no merge just to make it usable for us. I'll then say, so again, some of the usual commands you might find in a CAD package. So I could say shell, 1 millimeter is a bit too thin. And then I could start to combine these bodies together. Okay, so we're starting to see this particular component take shape. I can add a few details on here as well if I want, very, very easily. So let's say I wanted to apply some fillets or chamfers on the model somewhere. Just grab one of those edges and make sure I'm on the pull tool and go. Double click to select that whole area, apply to there as well. Well, let's say I wanted to apply some ribs to our model as well. So maybe around the edge of the component here. So I could create a feature very, very quickly. So I say, create a model, create a sketch, Maybe something like that. Okay, then again, you can see this is fully customizable. It's very intuitive the way this actually works, this modeling process. Okay, so now hopefully I can create a feature out of this and rotate that pattern around to create a few ribs for myself. And obviously this will be made a bit more detailed than it is, but we'll stick with this for now. So if I say I want to select this protrusion, I can hopefully get Geometry Modeler to identify that protrusion. I see create a pattern for me. It's already what I want it to be, so let's say 5 or 6 per 180 degrees, and then I can create that pattern. So you can see how easy it is to generate that kind of geometry. You'll also see that if I start applying something that modifies the original feature, so such as these fillets, it applies that to all of the features in that pattern. Okay, so obviously that's a very simplified representation of what would be a housing, but maybe it will do for our little example here. So what I'm going to do is select that body that I've just created. Well, first of all, I guess I can check if it fits or not. It does seem to fit quite well. I can say send that to MASTA. Obviously, I would check if everything fits as expected. And then, as we've seen previously in this webinar, I can go forward, generate my mesh, convert it to an FE component, and then utilize it in my model. So you see there, for example, I now have connections for those 3 bearings. Of course, we would need to complete the housing, but that will do for our little example in this respect. So that was just a snippet of the modeling tools that are available. So let's have a quick look at some of the other things. So you've seen combine, you've seen pull. Move is a very effective one. So it isn't just applied to faces or entire bodies. You can move features within a body as well. So let's say, for example, let's try this one. So you see there, for example, that I've grabbed that feature there, and it's trying to maintain all of the information I've added to it, so the fillets, for example, but it's moving the entire feature on top of still connected to that body there. So it's highlighted the feature and moving it, but it's still maintaining it as one solid body. Okay, you do have assembly features on here as well. So if you did want to actually add multiple components to this and then reorientate them and move them into position, you can do that as well using these assembly tools. So just creating connections, creating relationships between the different components. I've shown you the faceting tools to some degree in one of the other examples, as well as repair and prepare. One more thing I've just thought of is the measure capability. Something that people were asking for in MASTA quite a lot is the ability to measure between any 2 selected surfaces or selected faces in a MASTA model. Go on your Pull tool or Move tool, and then we have this Measure tool down here. And this allows you to select two faces and see the distance between them. It allows you to see information on circular faces, on entire bodies, angles between faces, and of course there are many other options available in here as well. They'll be covered in more detail in the actual workshop sessions and in the corresponding tutorial videos that we'll have available as well. Okay, so one of the other things very quickly I wanted to show you was working on asymmetric shafts. And again, this is very easy to do. It's arguably a lot simpler than generating a housing. So let's say, for example, we were looking at this differential carrier here. Again, this is the model that was taken from MASTA, if you remember. And I could very easily start cutting out the things that are relevant to me. So let's say, for example, this face here, I want to make sure that I have the holes for the differential pins. So I'll immediately go to Sketch. It will begin a sketch on my selected face. I could go for Project to Sketch and select those areas. Okay, and I could just go for Pull, go for all of those, and I'll say Cut. And I could create the cut all the way through that required component. Now, if I just isolate those two, so hide all the others, this is my required section. I'll combine those two components together. And then again, I can just start playing around with the geometry here to actually make it a bit more realistic. Because obviously this is based on the MASTA shaft that was used to generate the shape within MASTA itself. So again, I could start adding a bit more detail. Could add some fillets or chamfers. If I section this somewhat, I can start to put detail on the inside as well. So one of the points on this might be that it's radially asymmetric. So there might be thicker material in some places where there doesn't have to be planets, and thinner where there does. So Geometry Modeler has quite good sectioning capabilities. So you basically just have to choose a section plane, but you have full control over its position, over its rotation, and it highlights things in a very useful way as well. So if I turn on all the internals here, for example, I can see all the different components in loads of different colors. And then I can still modify the model whilst it's sectioned, which is very powerful indeed. Now, let's say I wanted to add those additional features here. So I can create a sketch plane on that section cut and then start to modify that information. Okay, so I'll trim away some of those extra curves. And then there is the start of my changed geometry. Okay, so I'm going to repeat this pattern first of all. So I'll repeat this around here, say 3 instances for 3 instances for 360 degrees. To get those in the right place. And then I want to combine those together. And you can see here what I'm trying to create. So based on the MASTA shaft geometry, which was basic for this shaft, we've now managed to create our radially asymmetric component. Now I'm not saying that's complete, obviously it needs a lot more work on it than that. But we'll then be able to send that directly to MASTA, as we've seen several times, and continue our optimization analysis process. Okay, so I think that's about everything I wanted to show you for today. So hopefully that's a nice summary of SMT's Geometry Modeler. If you are interested in any other information, of course you can ask away. And as I've mentioned, this functionality hasn't been released quite yet. It's currently in beta phase, but it should be within the next month or two that we see this being officially released. At that stage, if you want to trial this out, you can ask us for a trial license of the Geometry Modeler, and we're more than happy to provide that for you. In the meantime, please keep an eye out in your emails. We will be running a longer workshop session, should you be interested, at some point in the coming weeks, and there will be some shorter tutorial videos also being introduced to our Wistia pages for when this actually does get released and you need to learn how to operate it. Okay, so that's everything. Thank you very much for your time. I hope it's been interesting for you. Yeah, and we'll speak to you in the next workshop or webinar.